Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, we're going to be taking a look at this XT motherboard. It was a motherboard I recently featured in a main channel video where I repaired that Book8088. And if you watch that video, you'll know that one of the chips that was bad on that laptop was the 82C88, the 82C88. It's this little IC right here. And to get the Book8088 working again, I actually borrowed the chip off this motherboard to put onto that Book8088. The 8288 is an Intel bus controller type chip. I think it has something to do with the ISA bus and other processor signaling. And it was used on the very first 5150, as far as I'm aware, and definitely the 5160, the IBM PC XT. So all these clone motherboards have it. Well, I wanted to revive this motherboard because it's the XT motherboard I use for testing periodically. It's the one I kind of keep handy. And I went and looked at my stock, and all I had was one old 8288 chip, which I've installed on this board. But once I installed it, this board doesn't seem to be working quite right anymore. So let's take a look at what's going on with this thing. And I want to find out if there's some fault on this board or if this replacement 8288 chip I put on here is the culprit. This is that motherboard again. It's a clone motherboard of some kind. I don't know who makes this thing. It says Rev2D there. Oddly enough, it's got the same number of slots as an XT, but it has the footprint for an extra slot connector that would go in between these two. Why? I don't really know. If you want to have that extra 9th XT slot, I guess. It's a 640K motherboard. It's a non-turbo variant. If it were a turbo variant, all it would need is some extra ICs and components right here, and then it would run at probably 8 megahertz or something like that. But as it sits just like this in its base configuration, let's just call it 4.77 megahertz, 640K, and it even has the same number of BIOS chips as the original XT, although these are just regular EPROMs. I think the XT uses chips that are not standard EPROMs, although I don't quite remember, so don't quote me on that. The BIOS that I have in here is actually just this chip right here, and it's the PC Turbo BIOS, but I actually do have IBM's BASIC installed on here as well. So if you boot this system without any disk controllers, it should theoretically go into BASIC. And yes, XT motherboards like this are so compatible with the IBM one. If I replace this PC Turbo BIOS, which is open source by the way, with an IBM BIOS, this thing will act exactly the same as the PC 5150 motherboard. Now here's the 8288, and you notice it has an X on there. Well, I drew that on there after I put this chip in here and it didn't seem to work. I just was wanting to remind myself that this was potentially the culprit, because before I installed this chip into here, this motherboard was working absolutely perfectly. In fact, it was working in the video with the Book8088, which was only a couple weeks ago, and I remember switching that chip back and forth between the Book and this thing, and when I had it back in this board, it worked totally perfectly. I have a CGA card in the motherboard, and it's connected to power, and of course this is connected to the RGB to HDMI. Let's see what this thing is doing right now as it sits when I replaced this chip. Hopefully the system is still broken. I don't want it to just start working magically. I mean, it was broken last night. And then turn on the cameras and it kind of works. That was like the Book8088 machine itself, where I put it away, it was totally dead, and then it kind of started working when I went to shoot a video on the repair. You have to watch that video to know what I'm talking about. So let's power this thing on. Let's see, okay. Oh, don't tell me it's working. No, you gotta be kidding. No, there we go, okay. System error 2. So the system posts, but what's going on is it has 640K of RAM, as you can see, but it seems to be having these system error 2s randomly and also parity errors. There it is, parity errors. So it's really not working correctly. And if it were simply a RAM problem, I would think the parity error or the RAM error would be consistent. So now it says question, 29898 is the address. You can continue yes or no. I don't have a keyboard, so I can't push the continue button. Power cycle again. Now we're getting the normal RAM count. I had it failing, oh, there, got to 360K, and then it failed, error number 2. I don't know if error number 2 is like a memory error, or it might be that it's configured for 640K according to the switches here, and when it doesn't get to 640K, like it's counting up the memory, and then it stops where it thinks the top of memory is, like maybe the memory sort of disappears. Well, I don't know, we're getting system error number 1 here. So what's happening right now, power cycled again, is exactly what we were getting before. Now it's not even posting at all. And I think if there's no working memory in the first 16K, that's what happens. It won't even post. There, it got 8K and then errored out. This is exactly what it was doing last night when I tested it. Only thing that really changed, I took the 82C88 out, put it in the other machine, and that made that other machine work. And then I found this Intel 8288, it's not a C part, and I stuck that in here. Now, it didn't have the X or any of these other marks on here. I just sort of drew that, and this was my attempt to indicate to myself that this is what this motherboard needed to work again. And I don't know if this 8288 in here works, and I also don't know if the non-C part is compatible with like this older version. It had like a 1978 date code on it. My assumption is it is totally compatible. I think the C version would just mean it's a CMOS process chip, which means low power and low heat. The one that's on here is a ceramic package, and it gets very hot very quickly, which is kind of typical for these older Intel chips. So last night, in addition to testing this motherboard, I started organizing down here in the basement, and I was going through a lot of these bankers boxes here and just taking out any motherboards I could find and consolidating them all into one place. Really just helping me understand like what I had down here. And while I was doing that, I found this, which is another XT motherboard. And other than the tape on the basic chips here, it looks like an identical motherboard to the one that we're dealing with right here. There are some subtle differences on this motherboard. It seems to have, well, besides it only has 256K on it, every single IC on this motherboard is in the socket. Pretty handy for testing. If anything, I should probably keep this one around for testing just because every single thing is in a socket, while the one that we have under test here has almost everything actually soldered onto the board except for the RAM and the BIOS stuff. And there are a few things in sockets on this, which you can see here, like this IC and this IC, and of course this one right here, ow, that's really hot. Those were things that I socketed myself in troubleshooting this board because this chip right here had failed on this board that caused some DMA issues. And in that process, I was socketing some other chips because I didn't really know what was wrong. And that's why a few things are in sockets. But this one, on the other hand, everything's in sockets. It also has a V20 chip in here, a nice ceramic original V20 chip from NEC. That's kind of cool. Like that one, it seems like most of the chipset chips on here are of the NEC variety, which kind of makes sense why they would go with a V20. Before I do any kind of swapping around of anything, let's just double check, because I don't want to take chips off here and swap them onto that board in case there's an issue. I'm going to swap the BIOS chip over so that we're using the exact same PC Turbo BIOS here. And I just noticed one little fault on this board is it looks like, well, there's a problem with the keyboard connector. It still should work, but it looks like it's kind of snapped off. I do also notice some check marks on here, which means I've tested that RAM. I don't know what happened to the rest of the RAM. Maybe I stole it. So let's see what happens with this motherboard just to make sure that it is working with the PC Turbo. Here we go. Remember, 256K or 128 is all we're going to get. That is not normal. Let's take a look at what it says for the RAM that's on here. Yeah, 256K chips on here. So it should have gone to 256K, but I'm wondering if it's somehow set to 128K. Theoretically, you could use 64 kilobyte chips on here, and if you populate the first two banks, you'd actually get 128K, because 256K if you had all four populated. There's a set of jumpers on here which let you configure the amount of memory. Sorry, that's a bit washed out. I'm just gonna replicate these ones on the motherboard we're testing here to be the same as what's on the other motherboard. I'm expecting at least it to count up to 256K, even though we only have 256K installed. Oh, it's stopping at 128. So maybe this motherboard has some faults as well. At least it's not giving us any kind of system errors, but then it also is just kind of freezing here and not continuing. Let's plug in a postcard into this thing. So at least wow, that's weird. That glitching was odd. I don't know if that got recorded. I've been having those problems with OBS lately. Not sure if it's my capture setup or what's going on exactly. Anyhow, I was saying we were gonna connect up the postcard, but it's mainly because I wanna hear if it's giving us any beep codes. Now you might be thinking postcards don't work on XTs, and generally that's the case. With this postcard at least, and I guess this BIOS, there seems to be some activity on some of the ports that this postcard monitors. It monitors more than just the normal postcode port, which is like 60 hex. And you can see we're getting some like activity here. I mean, it's FF, I don't know, the numbers change around a little bit. And that kind of gives you an indication that there's some activity on the CPU. It is odd though that this motherboard is freezing. Now I didn't have this marked as bad. I found it in a bag, anti-static bag, and usually I put a note on there that says, bad motherboard, you know, blah, 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 don't use, etc., etc. Clearly I didn't market this one as such, and it's definitely not working very well. Nope. Whoa. Oh, so that time it worked? All I did was sort of push on some of the chips as I was talking there, and it freaking worked. Now, it said it was booting into BASIC, but didn't boot into BASIC at all. It booted into what, well, it's trying to boot the floppy disk. So I grabbed a keyboard here. This is an XT-AT compatible keyboard, so it works with both. Let's see if this keyboard jack is working. Okay, I plugged in the keyboard and we lost the video signal, but this is not the RGB to HDMI. This is literally like my HDMI switcher has kind of malfunctioned or something. Technical difficulties down here in the basement. We're still on the right input. Ah, there we go. Okay, so yeah, RGB HDMI is fine. It was just sitting there waiting. Yeah, I don't know why that happens occasionally, and it must be whatever related to that little bit of a glitch. Okay, so I just had pushed down on the chips. Now it consists, oh, space to boot into BASIC. Ah, oh, look at this, Sun Up Computers. A total illegal copy of IBM BASIC. How hilarious is that? Anyhow, like I said, I had pushed down on all these socketed chips, and now the system appears to be working. I guess that is one of the negatives of having all these chips in sockets, is you can get bad connections, especially if these aren't the best quality sockets, just from the board, you know, sitting around or whatever. In fact, while this is off here, I just turned it off. I'm just gonna do this again and give everything a little bit of a push. And maybe I'll reintroduce that problem we were having, or it'll stay away, I don't know. But anyhow, what I do know for sure is the system obviously is working now, which is good, because that means that we can take any of the chips off this one and try them on the other one, just to see. Okay, let's see if that did it. Just to see which of them is the bad chip on the other one. Uh-oh, I reintroduced the problem. No, it was freaking working. And now we're back to it not working again. Well, I should have left well enough alone. System was freaking working, and now it's not. But this wasn't even the subject of the video. It was the other motherboard. Ah, we're stuck again. I'm just gonna manipulate the board a little bit here. Oh, that really made it unhappy. That's fascinating. Well, I was fiddling around with this board for several minutes here, and I can't get it to get past 128K again. I know it worked, and it was after I manipulated it, and we had it booting several times. There it goes again. Now it just started working. What is happening? I wish I knew what chip it was, or like what socket is bad on here. Is this consistent now? Oh, it's consistent. These problems are difficult to find. Trying to figure out which is the bad chip. It's kind of like the Book8088 with its issue. The worst types of problems, they're very hard to find because, you know, well, I mean, luckily this one exhibits itself very quickly. But I don't know which chip it could possibly be. I'm sort of pushing on all of them, and magically it's working now. I bet you if I manipulate the motherboard, it will stop working. Okay, I'm just gonna give it a little bend here. There we go, put it back down. Is it still broken? No, it's still working. All right, well, I'm gonna stop messing with this one for now. Could be a problem with one of the bonds inside one of the ICs, just like on the Book8088. But either way, what we do know is the system is seemingly working. It's going into BASIC properly, which is excellent. That means that the 8288 that's right here, we know is good. It's working well. System is running properly, CGA, everything. So let's swap that over to the other motherboard and see if that fixes that one. All right, in goes the BIOS chip. And here's that NEC. Let's look at it closely here. Focus. 8288. So this is not a C variant. This is just an 8288D. Right. Ceramic package as well. So out comes this, you know what, before we do anything, I don't want to jinx myself. Let's just power this machine up and make sure we get the same fault before I go doing any kind of swapping. I don't want to jinx myself and have the machine, this one, just suddenly start working properly. All right. No way. No way, no freaking way. Okay, I was like, it's counting up the RAM and it's just working. It doesn't make any sense. Yeah, it's just as messed up as the last one. Okay, excellent. I just was scared that once again, we got a machine that sort of fixed itself. let's get this out of here. This unknown condition one that I found in my parts bin. And let's pop in this NEC part. Now I'm going to add, by the way, that I only had this one spare chip and it was all scratched up and, you know, unknown if it worked or not. I didn't have any more of these in stock. I looked through my inventory. I have tons of XT chipset chips, like all the other support chips that go on here. Maybe not the clock synthesizers, but all the larger chips, I had plenty of those. But none of these except for this one single one. So only when I found that motherboard last night, the other motherboard that is, I was like, oh sweet, it's already socketed too. So we could just do a quick test. Now I did go ahead and I already ordered 5 more of these 8288s and they were the C variants, I think UMC brand from eBay. When those show up, you know, maybe that can replenish the one on the other motherboard if this does fix the problem. But of course, I don't really know if this is just not some other fault that's on here and this is completely unrelated and it's just a red herring that the motherboard went from working to not working when I put this Intel part in here. Now I have to admit, I've never seen this kind of issue. So if this machine works now, with simply swapping this chip, that'll be a first for me. That chip like this would cause random RAM errors. Powered it on. No, that was not the problem. Interesting. Okay, so it was completely besides the point that it stopped working. Unfreaking believable. So how strange is that? That I didn't really change anything else on this board and it went from not working. Yeah, okay. I mean, we're getting system error 2s. We haven't seen the parity error yet, but I'm assuming they're somehow related. Let's just see if we can get a parity error out of this thing. Yeah, there we go. Okay, that tells us there's another freaking fault on this computer. I'm gonna take the number processor out of here. This is an Intel 8087, I think, -3. I'm kind of at a loss. System error, so definitely not that. I've got 8K of RAM. I mean, there could well be a RAM fault on here, and it is empty RAM. Now, empty RAM in this type, 256K, is not a problem. Is 64K chips that are the bad ones, the ones that are in 64s. These are fine. The problem is with this machine is the RAM errors are completely random and they're all over the place. So that's not reassuring as to like what's going on with this thing exactly and why it's just giving us these random errors. So one thing we can also do is pop in a V20. I don't remember what testing I did with this motherboard in the video with the Book8088. Obviously this other one here has a V20 on it. So let's replicate what's on this board with this one. I mean, I've never seen a situation where an Intel processor didn't work and you had to go to a V20 for it to actually function. I just popped this V20 out and this leg is bent over. I'm wondering if that was the issue. Perhaps it was just making contact ever so slightly with the connector in the socket, that is. So I'm just going to repair this pin, bend that back over. I like these needle nose, by the way, because they aren't knurled, they're flat. So it doesn't kind of wreck things. That is possible that this was the problem, and this probably was something that I caused at some point, you know, swapping the chips around. I don't know if this was the original processor in here, but let's give this a try. I am not anticipating that this will suddenly make this machine work. This is the one with the random errors. Not right away, we got a parity error. Okay, so it's not the CPU. And as you can see, yeah, this is changing frequently. All right, well, nothing is wrong with this chip. So that is something that I do know for sure. So I'm back to the motherboard with the 128K RAM issue, but I put the V20 back in there with the pins straight. And let's see what happens now. Okay, oh, I also put the 82, oh, it's counting up. Okay, I put the 8288, no, 8288, yeah. I put the Intel one that was in the other motherboard that was having issues. And we're working. So there's nothing wrong with that chip. So I went ahead and ordered those chips on eBay and I didn't need to. Luckily it was only like $11 shipped for 5 chips, I think, so it was pretty cheap. But I just was pretty sure when I popped that chip in that motherboard and it just stopped working, that I'm like, oh, obviously that's the issue, right? Like, it just makes sense. All right, well, I think the thing that's totally obvious is that this motherboard, even though I thought it was the 8288, that was not the problem, and there is some other fault on here, either with the RAM or with one of the other support chips. Of course, there are no schematics for this motherboard, but luckily all you have to really do is look at the IBM PZ XT schematics, because this is a total clone of that. There are some slight changes, but for the most part, stuff is in the same position, same parts are on here. I really think there's like not a single custom chip on here other than like the chipset stuff, but like no gals, no pals, none of that stuff on here. Oh, and just as I said that, it looks like a pal is right here on the board. And that is in a socket. I could switch that out with the one on this board, just so we can see. I wonder if that is somehow related to the RAM, because it is right near it. Do the signals on the back go from that to the RAM? Not obviously, but I think it might just be worth popping that PAL chip out. It is socketed on both of these, and just giving them a quick swap just to see if that makes any difference. I wouldn't be surprised if the PAL, which seems to go to a jumper block that's near it right here, has something to do with the ROM BIOS stuff. And that's because, unlike the original XT, you can set some jumpers on here. They're not really, well, I populated them on here, but they weren't originally, and they're not on this motherboard. You can set jumpers to change the size of your EPROM. So you could use larger EPROMs. You don't have to have quite so many like you did on the original 5160. So I wouldn't be surprised if that PAL has something to do with just these jumpers. It just adds a little bit of extra logic because they didn't have room on the board to add a bunch of logic chips. You can condense that all down into a quick PAL chip here, and then it allows you to select the ROMs and do that kind of fancy ROM size stuff. And yeah, I could see it goes to these unpopulated jumpers right here. There's a bunch of traces. So it might well be that. But you know what? It only took me a second to make this swap, even though I don't think it's going to make a difference, but let's just try it anyways. We're back to the motherboard with the issues. It's got the PAL chip from another motherboard. It does also have the 8288 from the other motherboard, and the V20 CGA cards in. See what happens. I am not, oh yeah, immediately failed. All right. I put the original PAL back in here, and I notice if I push Y for continue, it does try to count up. And then we just keep getting system error number 2 over and over again. Kind of reboots. It also notice it thinks it has a clock and a game port when that is clearly not in here. And I don't recall the BIOS auto-detecting those components on the other motherboard. I think it always just said 8088. You can hit continue on this. It's pretty hilarious with the parity errors. That's a function of the BIOS, by the way. The original IBM BIOS would just halt at that point. But this one does allow you to do some kind of continuation. Oh, system error E8. Oh, now we're in monochrome. Very interesting. It's like the system is even worse now. I can't even continue, and changed into monochrome there. Are any of the RAM chips hot? No, they're not. Of course, it goes without saying that a failing RAM chip could easily cause this issue because maybe it's failing at random points. We did see it count up the memory though, all the way up to like 400 something K one of the times when I powered this motherboard up, or maybe even 500K, which would imply that it was getting all the way into these banks of RAM here. These are 256K each. That's the first 512, 64 and 64. So it's 512 plus 128K, which of course is 640 total. And I think it was like in one of these banks when it crashed, but maybe one of these RAM chips is causing spurious readings, like it's kind of talking on the bus when it shouldn't. Or frankly, it could well be a ROM that's doing that too. Like it could be just one of the data bus lines is bad, or it could be one of the bus transceivers over here that's doing it. There are lots of possibilities, unfortunately. Now, I think what I have over here on the side is the IBM 5150 Diagnostic ROM. Is this even the right pinout to fit? No. This just says it's for the for the 5150, and there aren't even enough pins for it to go into that socket, so it's not compatible. I know this ROM itself would work on this motherboard though. I just need to flash it onto one of these correct chips, and then we could actually run this more advanced diagnostics. Alrighty, the diagnostic ROM has been installed in here. I got it from -0 degrees. It's like Landmark something or other diagnostics, I think. Let's see if this thing works. Oh yeah, it's running. Okay, here we go. So interestingly, by the way, it's a 2764 EPROM here, so 8K, and the file I downloaded was 32K. But I looked in the file, and it was just they repeated the ROM 4 times in there. So just loading that file onto here, obviously I knew it was going to work. Memory refresh. Is this where it's going to fail? No. Oh, everything is freaking working. I think this is normal. This is the CGA test. Yep, present. Scan lines. Everything is passing. What is happening? Is this simply just a memory issue? We don't have a floppy controller. Huh. Very interesting. I'm not super familiar with this particular diagnostic ROM, although the really nice thing about it is from my recollection, it runs even if you have no working memory. It does so by not using the RAM for at least some of the tests. Diagnostic summary, no memory errors, and it lists the bits, so 8-bit data bus on this processor. Failing bits, there are none. No false parity errors. And yet it doesn't work with the real BIOS in there. And I know that BIOS worked. I've had that in here forever, and this motherboard worked for a long time. I've used it for all sorts of other testing, and there were no issues. And then we took that Turbo XT BIOS and put it in the other motherboard, which is basically the same motherboard as this, and it freaking worked. I wonder if I should just put a floppy controller in here to get past this this annoyance here. I wanted to test RAM. Test RAM, please. Total errors 2. There we go. Okay, here we go. It's testing the RAM. Ah, bad bits. Memory error at 2C1FC. It's going to keep testing here because, like I said, it doesn't require working memory for this test to run. So it's telling us that we have 2 bits that are bad. Just from, I mean, maybe I zapped the board with static. I don't know. That's kind of unusual. Generally this stuff sits around in the basement and gets tossed around, and I found these in boxes of junk. It's not like the things have had good lives, inside static bags. In fact, I usually keep these in static bags now. I don't leave them around. But it's telling us we have 2 bits that are bad, 1 and 6. Okay. Parity error at address. Okay, wait. Memory error at address 2C1FC. Parity error at 9C007F. I mean, that's like totally 2 different total areas of RAM. Very weird. What I think the problem with this particular diagnostic is, one of the things I remember about it, is it doesn't have a running log of RAM errors. So like say there's a bunch of RAM errors, it doesn't give you like a historical list. So if there were a bunch of RAM errors detected, I think failing bits would be appropriate, would tell us what they are, but the actual addresses, which will give you the info you need to figure out which bank the problem is, that stuff's not available. So I kind of think what you were supposed to do is, fix the RAM error that's indicated there and then run this test again, which is slow because of course it's doing all this floppy stuff, which doesn't do anything. And then, you keep going, keep having fix the errors, fix the errors, fix the errors. It does say total errors has only been 3, and that's floppy read, floppy controller, which we know those are not actual errors, and then 1 RAM error. Now there is a parity error. Now parity on these motherboards, while this runs, I don't want to touch it too much, but there are 9 chips per bank because it actually has a parity RAM chip. If you have a bad parity RAM chip, you get all sorts of spurious RAM errors in the rest of the memory, which is not accurate. Now that false parity error thing, maybe that's somehow it's able to detect that the parity error isn't real, I guess. I don't know. Generally, the parity error is just there to help the system detect a RAM problem because it's like a checksum for every read or write. Essentially, there's an extra bit there. That allows the hardware to know, oh, something must be wrong here, and then it halts the system. It's kind of an extra level of error checking. Kind of think of it like ECC, but like a very early version of it on these systems. A lot of systems back in the day didn't use parity RAM, Apple II, Amigas, and Macs and stuff like that, but PC, IBM did install 9 chips per bank specifically for that parity error checking, and there is some extra logic on the motherboard that does that calculation for every single memory access. Now the funny thing is about the parity error that it shows there is up in the 9XXXX, and if you see at the bottom right above copyright, it says address 78 000. That's what it's testing right now for slow refresh. Slow refresh means I think it writes to the memory and then it waits a little while, reads back, and looks for degradation of the bits, which could have an indication of a refresh circuit problem on the system. Anyhow, it says the parity error was detected at about 9C, which is like way up in the top of memory, but the RAM error they detected is down in 2C. So we might be dealing with bad parity memory circuit, like the circuit in the motherboard that actually tests, that does that calculation. Maybe it's bad. I mean, the only thing I'm going to be able to do here is write down the errors there. I should find a piece of paper right now, write down those errors, and then we will run this test again and just see if those errors move. 2C1FC, 6 and 1, and then parity. All right, so it's running through the test again automatically. And the refresh stuff was fine. Anyhow, it lists the switch settings. So for the XT, looks like it is, I'm just checking if it matches. Yep, it completely matches exactly what's shown right there. So that means it's detecting the way the switches are set properly. And of course, the original 5150 had a different set of switches, which is why it lists them both. And I think what I need to let this do now is run through again the RAM test, which is going to get to in a second. And then we'll compare these readings here from the last one and see if they keep moving around. Because obviously when we powered this thing up with the stock BIOS, we were getting parity errors and RAM errors like randomly all over the place, which definitely indicates that there's some other kind of hardware fault on here that I don't think is actually a RAM problem. Limited as this BIOS, this diagnostic BIOS actually is, it's still very helpful because you could have a system that's not posting. If you have a RAM error in the first 16K of memory, your system will act totally dead. It will not, or maybe it'll beep, but it will not actually do anything. This ROM, on the other hand, will still display if you have an MDA or a CGA, or I guess EGA card, because it says EGA memory there. There we go. So EGA memory, CGA memory, and MDA memory. So my assumption is it works with those cards. Probably doesn't work with a VGA card. We have a CGA card in here right now. Anyhow, it'll get your system to actually show something where you wouldn't get that otherwise. So it's very helpful with that. All you need is an EPROM programmer like a TL866, or this is the 3rd generation version right here, and then a blank EPROM that's the right size for your motherboard. I think the later versions of the XTs use 250 or 32K EPROMs. They condensed a bunch of the ROM into one. But this older clone here, oh, it's good. Here we go, RAM check. Ah, look, parity error. Oh yeah, totally different address now. So parity error is 24000, and the RAM error now is 7C893, and then we have bits 7, 2, and 0. And that doesn't match at all what we saw on the first pass. So that definitely indicates, I mean, I'm thinking this can't be a simple RAM error. There has to be something wrong with the way the RAM is communicating with the rest of the system. That's the only explanation for these completely random errors here. And the only way to know for sure on what's happening with the RAM is to go find the schematics, because like I said, this is a copy of the original XT motherboard, and I think the RAM is behind bus transceivers, like 245s or 244s or something like that. And if they're misbehaving, then we're gonna get potential spurious info back. Or if what's telling those drivers to turn off and on are misbehaving, then that could cause issues as well. Well, I don't need to run this test anymore, so I'm going to shut this off. And that's because just that second cycle, the fact that those errors were completely random again, really reinforces what the stock BIOS was giving us, which was exactly the same thing actually. So that really does tell us that there's a problem with bus transceivers on here. And if I switch to this camera here, we have some bus transceivers right here that might be used for the RAM. There are also latches on this thing that are also used for RAM. And if we zoom in on this thing, look at this. What brand is this? 74LS244. So those are buffers. Those are just buffers. Here's a bus transceiver, latch, buffer. And it wouldn't be too hard for us to figure out, actually, if we get the multimeter out, even without schematics. Pin 2 on these RAM chips here, which here's pin 2. Pin 2 and pin 14, are they common? No, they're not. So one is input, one is output. I can't remember which is which. Let's just see if these go to these chips here. I'm not finding it on any of these chips right here, but I am noticing that that 245 there is kind of crusty. Oh, you know what? I was on a parity chip there. That was a mistake of my part because I'm looking for data bus stuff. Parity stuff is calculated separately. I think on the XT, the chips on the far edge of the motherboard there are parity, and those go to the parity chip that's doing those calculations. There we go. Okay, so that's data bits. Let's see. So theoretically, if I go to the next chip here, there we go. Yeah, it's okay. So it's this chip right here. This is handling at least pin 2. Yeah, there we go. It's that one as well. Let's see if 2 and 14 are common. Oh, they're common anyways. Okay, so not for parity, but for the rest of these 2 and 14, which is the in and out on these chips, are common. And it's this crusty old 245 right there. And check it out. I think that had some corrosion on it. I think what happened here is there was like something in the slot like this one with a battery, a NiCad. You see, it's kind of off color. See how dark the gold is there, and a nice gold. That's not so nice. I used like anti-corrosion stuff to remove that, but I think some battery leakage happened right in this area. And I noticed this chip is in the socket too. I did that, but I think that was not the problem. I think what failed on this machine was this chip here. This was for DMA. And I think it was probably related to the same thing. So I wouldn't be surprised if this chip, I think it was this one, right? Was this the RAM one? Let's just double check that real quick. Yeah, it's that chip right there. Let's see if this one is in play as well. No, it's probably for addressing or something like that. So yeah, I'm kind of suspecting that it's this chip right now. That is where my hunch is lying right now, because we're getting random errors. Now, the read errors and the parity errors. Now, if that chip were bad, we get read errors. But this chip or the parity chips here, if that circuit is working okay, the problem is that the RAM errors are going to be caught by parity errors. Like that bit's not going to match always. So random errors in the RAM is going to cause random parity errors as well. Whoops. Now I'm also curious, are the ROMs and the RAM on the same data bus? So let's go to pin 14 here, which we know is right there. And let's look at the ROM chips here, because I want to see. Okay, no, the data lines on the ROM chips are down here at the bottom, like all the way through here. All these ROM chips, all the data lines which are at the bottom here are parallel. And of course, these don't go directly to the CPU, and that's because the data bus on the Intel 8088 is multiplexed. So these most certainly go to one of these other chips here. There we go, it's right here. It's this 245 right here is handling these chips. Yep. So this one is handling the RAM, it looks like, and this one's handling the ROMs, and probably some of these other peripheral chips, and maybe even the ISA bus, which is how this stuff gets initialized. In fact, I think I have this stuff written on here, what's what. Where are the data lines? I have this little prototype board here which has pins installed in it that allows me to easily probe. Okay, so the data lines are on the top row right there. So I'm just curious if I pop this in. And the reason why I want to test this here is I'm going to go on like data line 5. So we're on 5, and let's see where that is. So it's not that chip. Oh, it is. Ah, yes, it is that chip right there. So, yep, okay. So this one also is connecting whatever's on the ISA bus to the same data bus here for the ROM chips, because it seems like the ROM's running, diagnostic runs, ISA bus is working because it's able to talk to the video card and show that stuff is working. So that chip right here, so this chip right here, not the RAM one, but the other one, is connecting ISA bus to the ROM bus or vice versa or whatever, something like that. And then that goes to a latch that's probably one of these chips over here that then connects it to the CPU. And the reason why you need a latch is because, as I said, the address lines and the data lines on the CPU are sharing the same pins. So at one cycle, it needs to be a data line signal, and on another cycle, it's an address line signal. So you have these latches here, which I think the CPU outputs an address signal, and then it gets latched, and then it goes to read the data bus. And yeah, so there's some extra chips over here that make that all possible. This is the main reason why the 8088 is slow, is because right there you're losing like half of your cycles to just that multiplex data and address line. So you take your 5 megahertz chip and you can cut that in half immediately. And that's not even counting things like the speed of the CPU itself, like running, executing instructions. It's just that alone takes away half of your speed. Now, something like a 6502, that does not happen. Or the Z80. I don't remember the Z80 is multiplexed. I don't think it is either. So those are just right away more efficient because of that simple fact. But there's a bunch of other factors as well, weight states and other things as well. Okay, so this chip here, I'm sorry, I think I called it a buffer. It's an LS245, so it's a transceiver. So we know the right side of this chip is what goes to the DRAM. So the left side is got to be connected, well, I mean, to something, probably stuff over here, which goes to the CPU. So let's just go on that pin and poke around on these chips. There we go, it's right there. So yeah, all 8 lines here will make their way over here, and this is probably what allows the CPU to communicate to peripherals while the CPU is in that phase where those multiplex address data lines are in data line mode. So it connects from here to there. But I wouldn't be surprised if this chip over here, so on the left side, like right there, probably goes to the other chips over here as well, which communicate to the ROMs and the ISA bus. Yes, it does. So what this is telling us is that because the ISA bus and the ROMs are working, because we're seeing CGA, we're seeing ROMs, everything's good, that kind of tells us that this chip is good. That means that the stuff from the CPU is making its way to the ROMs, to the ISA bus. It tells us that this chip is good, because again, this is making sure that the ROMs and the ISA bus are working. But the one that's dedicated to the RAM, that one seems to be the problem. Now, this chip has a couple control signals that go to it that are from other things on the motherboard. I don't know, some logic chips, right? That turn on the RAM at the right time, turn it off at other times. And that could be a problem as well, the control signal going to this chip. But because I know there was some corrosion on this board, these chips look a little crusty on the legs compared to these chips here, which look nice and shiny. These ones don't look so great. I'm really thinking that it's quite possible that that chip has failed. But it could well be the control signals that go to this chip. I mean, it could still be RAM somehow as well. We could have RAM. No, I don't think it could be RAM. And here's why. If a RAM chip were bad and it were like turning on when it shouldn't turn on, we wouldn't have random bits. We had 6 and 1 and 7, 2 and 0. I mean, that's too many bad bits that are showing up. And I don't think it's the parity chips that are causing these random bit errors. Although that's possible too. That would imply that the circuit for the parity RAM is causing an issue as well. Well, okay. I think I'm just going to quickly swap this chip out right here. I got plenty of those. We'll swap in another one. We'll see if that fixes it. And if it does, yay. If not, we'll keep looking. There we go. Socket is installed. That's the old crusty chip removed. I used a 74 HCT. I know it's a little hard to see, 245, so that's TTL compatible. It should work. This one was definitely super crusty. It doesn't look like it's all green, but there was quite a lot of just sort of nastiness under the socket there. So I'm pretty sure I have cleaned this up. I don't know what those scratches are there. I don't think I just made those, but I'm pretty sure I cleaned up the motherboard of all that corrosion. But you could still see a little bit of the off coloring right there in that slot. So yeah, it was that area. Always suspect corrosion as damaging these chips. It can go inside the body, but we don't know if that actually fixed it. We're totally guessing at this point. Let's put the cards back in here. Let's see what happens. This is the long test, so I'll do a jump cut here. Oh, I think, no, we're still getting problems. Oh dear, so that did not fix the problem. Very interesting. So yeah, it detected an error at 7C8E7, which does not match the other 2 RAM errors we had. And the bits that are the problems are 6 and 2, which, you know, we had those bad bits before. Interesting is there's no parity errors, but I think that this is just not really giving us useful info. going to switch back to that PC Turbo BIOS. It was a lot faster at telling us where the errors were. All right, PC Turbo's back in. This is going to just give us random RAM errors all the same. It's not even posting. Stop flashing. That 2 flashes is what you kind of get normally. Yeah, same error. I notice there's a jumper here, which I think is reset. Yeah, I touched that. Reboots. Okay, so that was not the problem. I falsely accused the crusty chip there as being bad when it wasn't. So I'm going to put this back into the socket. No point to waste a perfectly good chip, right? Just straighten the legs on this and pop that back in. All right, the original crusty chip back in the motherboard. I'm assuming we should just have, yep, same thing. Random RAM errors. We'll just do a reboot here. And it's just going to keep giving us random errors. Yep, parity errors, stuff like that. Is this a problem with the parity generator? Okay, so we have a couple possibilities now. We have a problem with the parity RAM generator, whatever is generating those parity calculations, or whichever circuit is driving the bus transceiver. Now, curiously, if I remove the bus transceiver from the board now that it's in the socket, let's just pop this out entirely, we will get a system that now does not work. Now, if we take out the PC Turbo BIOS and we go back to the diagnostic ROM, there we go. I'm anticipating that we will get the system to post. Yep, there we go. It will post even with that transceiver removed. It's just it can't talk to the RAM anymore. It just can't, it won't see it at all. Oh, look, right away, we're getting memory address errors. Oh, in the critical memory region. Right. So that's intriguing. Let's reboot this thing. So that's intriguing. So it tests that critical memory very quickly. And of course, that's going to fail, yeah, with random bits. And that's just because these are floating now. And we know that it's not a problem with the bus transceiver because we swapped it out and there was no difference. Although it does always pass that 16K memory test, even though the RAM test on the PC Turbo BIOS often says like error at 0K or 8K. Well, I think that's going to be it for this video. I was pretty confident that switching out this bus transceiver would have fixed this motherboard, but clearly that was not the case. I think for the next step, I'm going to be digging into schematics here for the next part of this video, where I'm going to try to figure out what drives this bus transceiver, because perhaps there's something wrong there. We'll obviously have to put the bus transceiver inputs and outputs, or at least the control signals, on the oscilloscope to see what those look like. That might reveal a little bit. Also, a possibility is the refresh circuitry for the RAM is bad. The RAM refresh is handled by the DMA controller, so it takes the burden off the CPU itself. So there might be an issue there. Because the system doesn't boot, we can't really validate that the rest of the DMA circuitry is working correctly. But there's enough information, I think, on the schematics here to figure out which signals to look at to make sure that the refresh is actually happening from the DMA circuitry. Anyhow, that'll all be in part 2, so watch for that. If you have any thoughts about what might be going on with this, definitely let me know in the comment section though. It is curious that, as I said, this motherboard was working and then it just stopped working. But when you have boards that have had corrosion in the past, like in this area, I mean, anything is possible. We could have a bad trace or something that's hidden under here that I just don't know about. I don't really know. So if you enjoyed this video, I'd appreciate a thumbs up. But if you didn't, you know what to do. Hit that subscribe button if you haven't already. Don't forget to check out the main channel. There's been a lot of PC type videos lately. In fact, with this motherboard right here, which has the 256K, I was testing that with a RAM board that I also couldn't get working. And that was a recent main channel video. I want to thank my patrons. Their names are scrolling up the side of the screen over here. They make it possible I do this full time. If you want to become a supporter, you can do so with the link in the description below. There's early access to videos, plus the higher tiers get behind the scenes videos and stuff like that. And that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.